Hi learners! In today's video, you will learn what the sector of a circle is and how its area is determined. If your lesson is in circles and you are on determining the area of a sector in circles, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. Let us first describe what a sector is. A sector is the part of the circle enclosed by two radii and an arc of a circle. You may think of a sector as a slice of pizza. The area of a sector, the shaded part, is the amount of space occupied by the sector. This area of the sector, as you see in the drawing, is just a part of the area of the circle. Remember that the area of the circle is pi r squared, where r is the radius of the circle. On the other hand, the angle created by the two radii enclosing the sector from the center of the circle is the center angle or sector angle theta. This angle is also just a part of the total angle around the circle, which is 360 degrees. This part-to-whole relations is equivalent, thus a proportion can be written as follows. Area of a sector over area of the circle is equal to central angle in degrees over total angle in a circle in degrees. Plugging in some variables and known values, like the area of the circle and the total angle around the circle, we have area of a sector over pi r squared is equal to theta over 360 degrees. This is where our formula for the area of a sector comes from. Multiplying both sides of the equation by pi r squared cancels the pi r squared on the left side of the equation, giving us the formula in finding the area of a sector in a circle. Thus, area of a sector equals theta over 360 degrees times pi r squared, where theta is the central angle or the sector angle in degrees and r is the radius of the circle. Remember this, learners. You must have the values of these two variables, theta and r, to determine the area of the sector in a circle using this formula. Okay, let us use the formula in solving some problems. Here's our first problem. Find the area of the shaded region shown in the figure below. Round your answer to 2 decimal places. Have you read the problem? Okay, let me ask you this question now. What are we looking for here? After reading, we learned that we are to find the area of the shaded region or the area of the sector. Let us check the figure. We see that the angle of the shaded region or the sector angle is given, and this is 230 degrees. The radius is given as well, and this is 18 feet. So both theta and r are given. We then proceed by applying the formula for the area of a sector. Plugging in the given values of theta and r, we have this. Remember that 18 squared means 18 times 18 and not 18 times 2. Putting all the numerators together, we have this. At this point, we can use a calculator to simplify the fraction. As I mentioned in my other video lessons, if pi is among the numbers in the expression, as in this case, try to put pi or input pi and not the value of 3.14. This will give you a more accurate answer. But if you are instructed to use 3.14, then go ahead and use it. The calculator that we will use is a TI-84 calculator. But you can use other types of calculator. You can also use the calculator in your cell phone. To input pi in this type of calculator, we hit the second key first, then pi. Okay, let us simplify this fraction. We will use pi instead of 3.14. We multiply all the numerators together using the calculator. And we get this. Dividing the product by 360, we have this. We have an answer, learners. So the area of the shaded region is 650.31 square feet. Did you get it? That was quite easy, right? Okay, let us look at this second problem. In the diagram below of circle P, segment XY and segment ZY are chords, and the measure of angle XYZ is 60 degrees. If PX is equal to 12, what is the area of the shaded sector PXZ? Give the answer in exact value. A figure is given here. Have you read the problem? Okay, what are we looking for then? You are correct. We're looking for the area of the shaded sector PXZ. Furthermore, we are to give the answer in exact form. Remember that for us to be able to apply the formula, we must have the central angle or the sector angle theta and the radius r of the circle. Let us examine the drawing and see if we have this. We do not have the measure of the central angle theta in the drawing. What we have is the measure of the inscribed angle. We also see that the inscribed angle and the central angle are intercepting the same arc. Remember that the measure of the inscribed angle is 1/2 the measure of its intercepted arc. The inscribed angle in the figure is 60 degrees. So what is the measure of its intercepted arc? You are correct. The measure of the arc is 120 degrees. Since the central angle is also intercepting the same arc, then we can get the measure of the central angle theta. Recall that the measure of the central angle is the same as the measure of its intercepted arc. So, what is the measure of the central angle? Right, the measure of the central angle is also 120 degrees. We now have the value of theta. Do we know the radius? Yes, the radius is given in the problem. We are now ready to use the formula. All we need to do is plug in the values of theta and r. Since we are to give the answer in exact form, we leave the pi as is and just simplify the numeric values first. Multiplying the numeric values in the numerator using a calculator gives us, dividing it with 360 gives 48. We then attach pi to 48 for the final answer. Therefore, the area of the shaded sector PXZ in exact form is 48 pi square units. That was easy, right? Let us have one more problem. Here's the problem. Matthew bought pizza at a restaurant. He ate a portion and brought the rest of the pizza home. What is the area of the pizza he brought home if he ate 2 slices? The diameter of the pizza is 14 inches and the central angle of each pizza slice is 60 degrees. Round your answer to 2 decimal places. A picture of the pizza is given. Okay, have you read the problem? After reading, we'll learn that we are to solve for the area of the pizza that Matthew brought home. Let us first label our drawing using the given information. Each slice has a central angle or angle sector of 60 degrees. The diameter is 14 inches. There you are. Our drawing is labeled. Looking at the figure closely, the pizza is cut into 6 slices. Matthew ate 2 slices, so he brought home 4 slices, right? To get the area of the 4 slices, we need to know the sector angle theta of the 4 slices and the radius r of the pizza. Let us start with the sector angle theta. Each slice has a sector angle of 60 degrees. 4 times 60 is 240, right? This is the sector angle of the 4 slices of pizza that Matthew brought home. Next, let us determine the radius. The diameter of the pizza is 14 inches. Remember that the radius is 1/2 the diameter. So the radius must be 7 inches, correct? We can now apply the formula. Next, we plug in the values of theta and r into the formula. Just like in the previous problem, we will use pi instead of 3.14. Multiplying the numerators together gives us. Dividing the numerator by the denominator gives us. Therefore, the area of the portion of pizza that Matthew brought home is 102.63 square inches. There you are, learners. We have answered the problem. Okay, let us summarize what we have learned on this video. First, a sector is the part of a circle enclosed by 2 radii and an arc of a circle. Second, the area of a sector is the amount of space occupied by the sector in square unit with the formula area of a sector equals theta over 360 degrees times pi r squared, where theta is the central angle or the sector angle in degrees and r is the radius of the circle. Third, an answer could be written in different forms. It could be in decimal form, which is an approximate value, or in terms of an exact value. When asked to write the answer in exact value, do not round off the numbers. Instead, write the value in terms of pi or in terms of fraction in its simplest form. Fourth, when solving a problem, you must read it and may read it several times to know what you're looking for, what information are given, and to figure out how this information will help solve the problem. Fifth, if a figure is given, make use of it. It is there to help you. This will greatly help you analyze and solve the problem. Okay, learners, hope this video helps. That's it for now. If you have any questions,